So, welcome, good afternoon. My name is Julia Reisinger. I'm from Technical University of Vienna. I'm an assistant professor for integrated industrial building design, and today I'm going to present you our framework Restock Industry, the digital framework for the circular reuse of existing structures for vertical production. So, in industrial building design, we have a problem, and it is like we have products and processes and the building, and they all need to be in harmony together. But the problem is they have varying life cycles. So product and processes change very fast because of different customer demands, technological advances, and the building, once you've built it, you have the building structure standing, and it's often in the way of production changes. So another big topic in industrial building design is that they're consuming a lot of land. Like one typical normal industrial building hall has around 20 to 30,000 square meters, but we really need to find new sustainability strategies regarding our land use, and we really need to bring down our new land ceiling. So every year we have an annual increase in land consumption, and this is where we have to do something against it. For example, the land consumption in Austria for operational areas, it's 3 to 8 hectares per day, and in construction areas, approximately 5 hectares per day. And so new areas are becoming very rare. Also, the productive land is becoming a very crucial competitive factor. And what that means is we really need to find vertical production and vertical building concepts in order to minimize new land ceiling. Another way would be to reactivate the existing building stock, the existing industrial building stock. So we have around 67, I'm talking about Austria in the statistics, we have around 67,000 industrial enterprises in Austria and more than 82,000 existing industrial buildings. However, every year 1,100 new industrial building permits get accepted. Although, and they're mostly built on green land, although we have 20,000 hectares of industrial brownfields not used and 6,000 unused industrial buildings. So what are the challenges? We really need to find strategies to have this productive reuse of brownfields and existing properties, which is quite difficult because most of the industrial building stock maybe doesn't fit the production needs, or it's already outdated. We need to find strategies with multiple use within one building, which is like very flexible for multiple use, and extended building lifespans, but also with simultaneously reducing the resource efficiency of the buildings. As well, we really need accurate life cycle oriented documentation of our building stock. So the existing building stock right now we have, it's not very well documented, but we need to find strategies in future that we are ready, what we build now is really well documented in future, that we can use it and reuse our building better. And another challenge we are tackling is the structural analysis of these as-built models is often not available, and if you have an existing structure with limited information, it's a very manual, time-consuming and error-prone process. And these challenges we are trying to tackle by our funded research project Restock Industry, the digital framework for circular economy-oriented reuse of existing buildings for vertical production. It's quite a big consortium of civil engineering, architectural, construction companies, and some informatics faculty, and we from integrated planning and industrial building. The research questions I'm trying to answer today, or in this paper, which we try to answer in this paper, is which methods and technologies are suitable for digitally recording and documenting the structural properties and the material consumption of the existing industrial building stock? And furthermore, how can we evaluate its reuse, modernization, and upgrading potential for vertical industrial use cases, always with a circular economy perspective. So the research goals are, we need to come from greenfield to brownfield. And what is very important to have this structural reuse, because the structure has a high amount of material used in the building, and it's the limiting and the material with the longest durability in the building. So the structural reuse, how can we reuse existing industrial buildings during relocations, expansions, or repurposing, instead of resorting them to recycling or disposal processes. Then, how can we go from horizontal to vertical? We need to find innovative vertical production concepts, meaning integrating vertical production concepts into the building assessment to avoid new ground sealing and extend the lifespan of industrial buildings. And furthermore, we go from manual to automation. So how can we automate the structural analysis of existing buildings by developing a scan to finite element method using artificial intelligence, with automated suggestion of retrofitting measures for industrial building structures when they are vertically updated. So in the next slides, I'm going to present you the restock industry methodology and framework and how we are going to tackle it. This is the research design of restock industry. So first of all, we have 10 real industrial use cases, typical production and logistic buildings, from steel and reinforced concrete skeleton structures. We go there, we fly with drones, and with photogrammetry and scanning inspections, we get the data from these buildings. We also do plan documentation of this existing building stock. In the next step, we receive the point clouds, and we extract the analytical parametric model for the finite element model, and we create an algorithm which automatically detects the structural joint detections from the scan and image data in order to have this as-built FAM model and fasten the process. Thereby, we also consider material, condition, and pollutants. And parallel, we need to find vertical production layout models, so we create this 3D parametric layout generator, which can be integrated into the finite element model. So if we have this integral modeling, we have a holistic concept, and we need to find ways how can we integrate these data into resource paths and material cadasters, but also look at what other parameters will be needed in future and what else can we gather and include in resource paths which are maybe not in there at the moment, and a novel assessment model for assessing the structure. And at the end, we are building, this is in the future, it's not happening right now, an AR on-site desktop visualization so that the user can go on-site with an augmented reality application and see different scenarios for vertical adaptation and retrofitting with real-time feedback. And we will do the whole proof of concept with our other 5 use cases and evaluate and optimize the framework. So this is how the restock industry framework looks like. We have this integral restock model in the middle, but we start with this automated generation of the analytical as-built finite element model by coupling the point clouds and image data. And first of all, we're going to reconstruct the analytical finite element model from point clouds with reconstruction and stochastic optimization methods, and furthermore develop a deep neural network for automatic detection of this structural knot connection to have them automatically inside. We are currently working on that. I can't show you final results of that. And then when we have the whole documentation, geometry, material, the condition, the age, and the pollutants within the structure, we can integrate them in the resource passports, but also identify these new parameters which are relevant for the vertical reusability of a building structure. For example, load, some safety in load conditions, so that in future you know, okay, there is like 30% still available for carrying additional loads, and that this is documented. Then this vertical production model. We have this 2D layout generator already available, and we are going to evolve this model with a 3D layout generator for vertical production planning. We are looking at very innovative production models or production techniques with a factory planner for vertical processes, and then we also relate them to modernization or retrofitting concepts for the structure. What does it mean for the structure if we go vertical now, and how can we adapt existing structures accordingly? And finally, this as-built finite element model and this vertical production model will be integrated in one computational restock model through generative design methods and for this holistic evaluation. And that we can integrate, in order that we can integrate a circular economy perspective, we need to find, there are currently circular economy assessment methods available. We are looking at them, we are analyzing them, and integrate them into this integrated model. However, we also need to see if these assessment models are lacking some kind of parameters which we can still integrate. However, for example, how do we compare retrofitting versus demolition and new construction? So we really want to motivate planners and building owners that they go with the renovation and reuse concept, not demolition and new construction, which is often still the case. And so we need to find ways, how can we measure this CO2 saving which they achieve by the structural preservation, and how can we measure that and take this as a promotion. Yeah, and finally, this model is real-time coupled to this AR on-site visualization and analysis map, and the user can then compare different scenarios with renovation, reuse, accordingly with demolition and new construction in the augmented reality environment. So we are currently working on this whole framework step by step. However, there are some limitations we have to address, right? So the framework is currently built for industrial skeleton construction, meaning for further broader applicability, we need to take this into account and adapt it to other types of buildings in future. Then the framework relies heavily on different emerging technologies. So we really need to explore during the process, by doing that with industry together, how can they really be integrated into current design processes that are really relevant for the market, and the interoperability to existing systems. And we really need a very high quality of this input data for our algorithms. So yeah, during the process we will be very, very rigorous in validation and sensitivity analysis. One of the last points is still building owners, decision makers, they still prefer the most economic, the most cost-efficient option, let's put it like that. And how can we overcome this thinking and find practical adaptations that people are not only evaluating and choosing, make decisions according to the cost performance. Exactly, and also we are in this project we are really focusing on the structure of the building. So we will consider some other building parts. However, it must be mentioned that there can be more, or there will be more CO2 emissions for other building systems, and we are not including energy efficiency considerations in our framework or in our research. thank you very much for the presentation. If you have any other questions, you can ask now.